Welcome to The Bee's Knees, a podcast wild about native bees. Wild and native bees are under threat worldwide. In each episode, we look at actionable things we can do to support these adorable little guys whose pollination work is crucial for maintaining biodiversity. I'm JC Meyer, and I thank you for being here. How often do you go with the nutritionally wise option when deciding what to eat? We've talked about bee nutrition in previous episodes, but today we're going to look at how bees respond to different diets. I'm joined by Dr. Etya Amsalem, whose recent study challenges a long-held assumption that bees know what's best for them when it comes to food. Her team explored how bumblebees respond to different diets. Some rich in protein, others packed with sugar or fat, and what they found might surprise you. Turns out bees, like us, don't always make the healthiest choices. Sometimes they overindulge or avoid certain nutrients, even when those choices don't lead to better fitness. We're going to look at what the implications of these bad choices may be. I started the discussion by asking Etya to define what bee fitness meant to them in their study.
Okay, so in our study, we measured fitness by reproduction and weight gain. So for bee, that means how quickly they activate their ovary. We can actually measure the size of the largest egg in the ovaries and how many eggs they lay and how much weight they gain from emerging until we finish the experiment. So all of those traits are super important and might change under stress. Now, in our study, we used bumblebee workers. That's a social species, and normally they live in a really large colony with a queen, but for the sake of the experiment, we separated them from the queen and put them in a group of 3. So without the queen, they activate their ovary fully in 1 week, and they would lay eggs in a very predictable time frame. So a group of 3 workers would lay on average about 10 eggs in 10 days. So it's really useful. It makes them really good system to test how diet influence, how it deviate from what we see in that setup.
So tell us about the different diets you fed to these bees in your study. Why did you choose the compositions that you did?
So we ran several experiments. Actually, we ran a lot of experiments in this study. We always used the same group of 3 workers, and they were all of the same age. So we took them when they emerged, and we gave them 10 days. And that's, as I said, important for the outcome of fitness. Now, for the control, the bees were fed a mixed pollen that was collected by honeybee and 60% sucrose solution. So that's the standard diet that is being used in commercial rearing operation of bumblebee and also in the lab whenever we rear them for whatever experiment we do. So on this diet, they would activate their ovary in a week, lay about 10 eggs in 10 days, and every worker would on average gain something like 30 milligrams of mass. So that's our baseline, okay? And now everything is compared to that. So for the manipulation, we took that control pollen, so we don't change much, we just add something to it, and we enriched it with different things. So we either used casein. Casein is a protein source. It contains all the essential amino acids. And we also use different type of lipid sources. So we use the canola or vegetables or flaxseed oil. And for each one of those, we tested 3 different concentrations. So we call it low, medium, and high. And when we manipulated the pollen, we kept the sugar as normal, as the control. So they got 60% sugar solution. Now, when we manipulated the sugar, we did it in the sugar solution. And in that case, we either changed the concentration of the sugar, so we used 20%, 40%, 60%, or we swapped the sucrose with different type of sugar. So we used either glucose or fructose. So all in all, we had different type of lipids, different type of sugar, and then different concentration of protein, carbs, and lipids. Those are the most important micronutrient in the diet of bee. So the idea was simple. What we wanted to do is to change 1 micronutrient at a time and then see what happened to the bee fitness and then also how much they consume. And we simply wanted to see if there is a correlation between the two, if they're able to regulate the diet in a way that benefits them. And that was the underlying hypothesis, that bee knows what's best for them and that they will regulate their consumption and they will either increase their fitness compared to the control by altering the consumption, or at least be the same as the control.
So let's talk about what you found. One impact you found was that egg laying and body mass, two things you were looking for, were negatively impacted despite the high food consumption. Was this surprising, first of all? And what consequences does it have for bees?
So the answer here is yes and no. Well, this is what we found for the protein. They over-consumed diet that were rich in protein, and then the outcome on fitness were negative. But this is not what we found for lipid. It was the completely opposite for lipids. They under-consume lipid, but then the outcome fitness were still bad. So this is even better because it looks like the eating pattern didn't match fitness outcome in no matter what direction they happened. It almost looked like bees were programmed to eat less or more, depending on the composition of the diet, regardless of how it affects them. But what we saw is that bee didn't do well on glucose, on fructose, which is kind of surprising because sucrose, where they did the best, is literally a composition of glucose and fructose. And we also find that they drank more on sugar solution whenever it was diluted, when it was 20%. And that too led towards a fitness outcome. Now, this could be a slightly different story because when we really reduce the sugar concentration, bees may not get all the carbs that they need. So they're trying to compensate by drinking more and more. But there's only so much a bee can drink, right? So it could be that's the reason for the outcome that we see with sugar. Now, if we combine the data that we see for sugar and lipid and protein, and we take it in the context of the lab or a commercial operation where the food is unlimited and we do not limit it in any way, we do see that bees seem to be kind of programmed to eat certain things, and they don't necessarily do it in a smart way that benefit their fitness in the long term. And I really like the example of my toddler liking to eat cookies for lunch. And nobody would come and say, oh, well, it's probably because she's missing some carbs. It's not, right? So I would not conclude about better health from preference. And I keep wondering why we do it for bees. So maybe we should change our perspective on how we determine what is an optimal diet for maybe an animal, not only for bees.
Yeah, do you have any other thoughts on that, on why they were choosing diets that weren't supporting their health?
We have a lot of thought about it, but they're all speculative, right? It could be due to evolutionary constraint. So maybe in the field or maybe in the past, they learn to prioritize protein because protein are less abundant. Maybe it's a physiological limitation where they are not able to process so much lipid or not able to store so much lipid, and therefore they do not rely on it. So when they see a lot of protein, they just munch on it. And when they see lipids, they don't like it. Definitely in the lab, when the food is unlimited and abundant, they're making wrong decision about what to eat.
So let's talk about bee nutrition, specifically like stress. I'm thinking about things like climate change, pesticides. How do they worsen nutritional stress for bees? And is there anything people or farmers can do to better bee diets?
So I think the interaction between nutritional stress and other stresses can be both direct and indirect. So usually it's not about one stressor, but often it's about the buildup of several stressors. And I think this was shown in many other studies showing that often the combination of stressor is much worse than the sum of a few stressors. Now, there could also be some direct links between nutritional stress and other stressors. And I can give an example. So think about flower resources. Let's say they're abundant around the colony, but now they disappear. Now, the bees are not just going to die, right? They're going to fly further to find food somewhere else. But if their energy level to begin with are low because of pesticides exposure, or if high temperature make all of this flying much more costly, then the overall trip become more costly, and the outcome would be less food coming into the colony and maybe of a low quality because they are forced to go nearby and not go further on to look what they really need. Now, for your other question about what people can do, most people don't know what is the nutrition value of different flowers. I don't even know all of them. So I would say that, we were focusing on what not good for bees, not what good for them. So my recommendation here would be very general. Probably the best thing to do would be to plant diverse native plant with varying nutritional value, right? So if you just have diverse plant, you probably cover different nutritional value, and you also want them to be available across the entire year. I would also think about practices that are used by agriculture, like monoculture, where you have miles of the same thing. Not good to agriculture, not good for bee either. We also need to keep in mind that what helps bumblebee may not be helpful for other bees, like osmia or honeybee. So we do need to get that information that is specific to a species. And more than that, what is helpful to a bumblebee queen is not necessarily what is helpful to a bumblebee workers. So we need to think about it throughout the season and support the different stages throughout the year.
Okay, so I'm going to put you on the spot. If you could redesign the perfect bee buffet based on what you found, what would be on the menu?
That's a tough question. So we don't have complete answer to that, but there are things that we already know. So I'll give few points and try to wrap it up by the end. So something I already mentioned, diet depends on life stage, right? So in a previous study we conducted, we found that when we enrich pollen with protein and we give it to young queen before they go to diapause, it's that winter dormancy that they spend most of their life in. They actually survive better in diapause when we enrich the pollen to a level of 4:1. This is the ratio between protein to lipid. And in comparison, the pollen that is collected by honeybee, which is normally a mix of a lot of plant, would often be in a ratio of 1:1 protein to lipid. So that enriched 4 times the protein. So the queen will do great on this, and they would survive longer in diapause. Now, we use the same ratio in our study in here with worker, and even though they preferred it, not only in our study, in several other studies that were doing choice experiment where they gave them 1:1 versus 4:1 ratio of protein to lipid, they prefer it, yet it's not good for their fitness. So what's good for a queen is not necessarily good for a worker. So this is one thing we can think about. The second point is we see a cross study that bees seem to be deterred by extra fat in their food. And it doesn't matter what kind of lipid supplement we add to their food, they just don't like it. Now, the performance on that kind of pollen are also not very good. But we don't know if this is because the lipids are harmful to them or because they just don't like the lipids and they eat less, and that's why they gain less weight and reproduce less and so on. So I'm thinking if somehow we can convince the bees to eat those lipids, maybe we'll find something interesting. Maybe that they're not programmed to eat them, but they could be useful for them. And think about all the costly, energetic tasks that they do in a normal colony that would require this storage of lipid. The third point is that I'm thinking this is the part that surprised me the most, and we're actually continuing that research now in my lab, is that sugar concentration seem to be critical for reproduction. And this is mind-blowing for me because usually we think about protein when we think about reproduction, but here the worker had unlimited amount of protein. They could eat as much as they want from it, but once we limited the sugar, they were not able to either lay eggs or activate their ovary. So now if you look at study across bumblebee, in the literature, you would find great variability in the amount of sugar that they receive. It goes all the way from 20% to 60%. So that could affect many of the physiological traits that we're looking at if this is so crucial for the reproduction. So I think for a start, we can standardize sugar level in their diet, and that would be a first step. So those are just a few examples. I think the bigger goal would be to first figure out what's a perfect diet in the lab look like, and then try to look at those micronutrients, not only in isolation, but also to see the interaction between them, and then to try to translate that knowledge back to nature, like how flour provide those nutrition and how we can manage resources to boost bee health. I'll also add another point in here. We need to keep in mind that when we are trying to optimize the diet of bee, and specifically of bumblebee, we're not only trying to understand their optimal diet in the wild, which is important, but it's definitely the next step. We also trying to optimize their diet in a managed bee that are reared in a commercial operation. Now, there are millions of colonies of bumblebee that are produced worldwide to support pollination services. And they're extremely important in greenhouse, for example, or for plant like tomato, where the flower is relatively big. So you need a relatively big bee that is able to do this buzzing behavior in order to pollinate the plant. And honeybee would just not be able to do the same job. So we need to think about alternative to other pollinators that we have, and we need to think about ways to support their diet in those operations, which are very similar to what we do in the lab, right? There they do have unlimited food. So those are two different goals, but I think one of them can lead to another in the long term.
So even pollinators have their version of reaching for the chocolate instead of the broccoli. As Etya explained, bee preferences don't always align with what's healthiest, and that has big implications for how we support them in a changing world. As habitats shrink and food sources become more limited, understanding these mismatches between what bees eat and what they need could be the key to better conservation strategies. Thank you for listening, and I would love it if you would recommend the Bee's Knees to a friend. Please also visit the website, the beesknees.website. You can sign up for our quarterly newsletter, The Hive, listen to past episodes, and catch up on your bee-related reading. Until next time, be nutritious.